Hi Qayyum. I have just one question. Can we see that question quickly? I have some doubt on that.
Yep.
Let me share my screen. Can you make me present it so I can share my screen?
Sorry, cannot hear you. What I need to
Can
do?
you make me presenter so that I can share my screen?
Okay, just a second. Now you can share.
Oh yes. This is one question I checked from the website. Do
Mhm.
you see my screen? Yeah. Uh,
Okay, link 1 is copper connection, link 2 is fiber connection. Okay, the fiber port must be the primary port for all forwarding.
yes.
Link 2. The output of show spanning tree command on switch 2 shows that the fiber port is blocked by spanning tree. Correct? It is alternate port. Okay.
This is blocked because Z00 is the lowest interface ID, right? So that's having the first priority.
No. It is not about the interface. It will never be about the interface. The spanning tree is running based on the switch. It is not running based on the interface that is connected.
No, the root selection, the port selection, either Z00 or Z01, which should be as a root, which having the lower ID, right?
Lowest bridge ID. The switch that is having the lowest bridge ID will be the root bridge.
That's okay. For the interface selection,
There is
which
not
inter?
there is nothing like there is an interface selection. There will be a link selection.
Okay, go ahead.
Who told you that spanning tree will select any one of the port if the port is lowest port or something?
I can show one example.
That's part of the tiebreaker, right? If everything's the
Yeah.
same, it'll look at that. That's what
It is
he's saying.
it is for root port or something, right? But for root bridge, what is the criteria? See here what it is showing me. If I can see, Robert, I can see on switch 2's output, switch 2 is not the root bridge.
That's fine. That's I understood. That's the root bridge selection. So switch one is the root bridge selection because having the lower MAC address.
Mm-hmm. So switch 2, if switch 2 is if switch 1 is the root bridge, then switch 2's gig 0/1 will be in the blocking port.
Why not G00?
See, it will select any one of the port. Okay, based on the spanning tree calculations, it will select any one of the port.
You mean on switch to any one of the port, either Z00 or Z01 can be blocking
Yes, but
and forwarding.
what is the lowest sender's port number over here? Lowest sender's port number is this. Correct?
G00?
00. So it will select this link 00 as the root link, and the gig 0/1 is becoming my
So
blocking link.
that's based on the interface ID, right? The lowest
Yes,
G0.
the
That's
interface ID. Yes.
that's what I was saying. Same thing I was saying.
Yeah, I just got confused. Got it?
Yeah, so now the answer here, so what should we do to make G01 as a forwarding port?
Okay.
G01 को अगर forward करना है, what should we use?
So you can change the cost over here.
You mean to decrease the cost, or yeah, decrease the cost, you mean, right?
We can decrease the cost, or
But
which command should, what they have asked you over here, which command should be entered on the ports that are connected to the link to resolve the issue.
it's not based on port.
So
It's
if I
based on
make the enter spanning tree port priority 224 on switch 1, okay. If I make this port's priority on switch 1 as greater, port priority on switch 1 as 224, then automatically this port will be removed from the root port, and the other port will be becoming the root port over there on the switch 2. See what I did on when I was doing MST, what I did, whenever I need to change something, whenever I need to change the uh, link, what I did, whenever I need to change the link, and what I did, I changed the cost on the other side. But when I need to do it on the root bridge, I need to do it on, I need to change the port priority. If you remember the last lecture.
Mhm.
So
But
what I did,
port,
I changed the port priority on the root bridge. I didn't change the port priority on switch 2.
okay.
Okay, I
But
changed the port priority on switch 1.
okay, sorry. My question here, the port priority on switch one for link one is 128. What is
Mm-hmm.
your on switch two? The same will be on switch one, right? The port priority for link one is 128.
Pawan, can you give me a minute, please? I'm getting a call from my boss. Can
Ah,
you
yes,
give me a
sure,
minute?
sure. Yeah, take it.
Yep, sorry. So what you are asking?
Uh, so you are saying this option is correct one, which I have just selected randomly. This is the correct one.
See, you can select this second one also. On switch 1, if you lower the port priority, see there is no need to lower the port priority on switch 2, because port priority will be done at the root bridge only. This is not the root bridge. Switch 2 is not the root bridge. Switch 1 is the root bridge. The output they are showing is of switch 2.
Mm-hmm.
Who is the root bridge over here? The root bridge is switch 1. Okay, because you can see I'm not having anything over here for the root bridge. This is the root bridge. I'm not having any of the output on the switch 2 screen. Spanning tree shows spanning tree that this is the root bridge. So switch 1 is my root bridge. And if I want to make this gig 0/1 as my forwarding link, then what I need to do, I need to make this link's port priority as lower. Understood? And if I am doing it on switch 2, I need to lower the cost.
Okay.
If I want to select this link, gig 0/1, and I need to configure it on switch 2, then I need to make the cost lower. Got it?
Mm-hmm.
So
Right.
lowering the port priority, and it says on switch 2, they lowered the port priority on gig 01 to 32.
No,
Right.
we don't have to do the port priority thing on switch 2 because port priority will be only working on the root bridge.
Okay, so if I lower the port priority, it doesn't matter about the blocking and forwarding,
Yes, it will
my
not
designated
matter
port
on the
versus
non-root bridge.
alternating port?
It will
Okay.
not matter on the non-root bridges. If I am having a non-root bridge and you will lower the port priority on the non-root bridge, then it will not matter. See, we have seen in the last lecture these things only. In the MST thing, I was having two links in between the switches, okay, and I wanted to make the other link, the second link was in the blocking state, and I wanted to make the second link come up, okay, and the first link should go in the blocking state. So what I did, first I went into the switch 2, which was not my root bridge, and I changed the cost, and I showed you that the link came up again. The link changed their status to forwarding, and the other link went into blocking state because the cost was lower. Then what I did, I changed the scenario with the default scenario, and then I went to root bridge, and on the root bridge I changed the port priority. If you remember, if you see the last lecture's recording, you will get the things.
So let me just ask one more question. It should be looking at cost first, right? So shouldn't the fiber port be a faster, a lower cost than?
But see the options over here. See the options, Robert. There is no option for cost given over here. Now we have to think about only port priority, where I can give the port priority options. I have 4 options and all the options are of port priority. So where I can give the port priority, I have to see the options. What are the options given to me? Like if I
Right.
go with the steps, it should see the lowest cost first. You are right. Then it will come to the lowest. If the cost is having a tie, then it will come to the lowest port priority. But here we are having only options for the port priority, so we cannot think about the cost anyways.
Gotcha.
I think I got it. Last question to you. So the cost 4 here on switch 2, this will be same on switch 1, right? The
Yes.
cost values.
Yes.
But the priority will be different, right? So on switch 1, it will be it may different. It may not be 128 and 32 on switch 1. It could be different, right?
It is 122 and 128 and 128 on switch 1 side.
Okay.
It is both the links. Default priority, port priority is 128 only. See,
Okay.
what is the question? The output shown, what he has done. An engineer enters the spanning tree port priority 32 command on gig 0/1 on switch 2, but the port remains blocked. Why? Because he has selected the wrong switch. He has done on switch 2. The same command he has to give on switch 1, and the link would have come over here, because the port priority is checked on the root bridge. Port priority will be checked on the root bridge. Understood?
Yeah, it's clear to me.
Sorry?
Yes, this is clear to me.
Okay.
Clear.
You can stop the sharing now. Thank you. Anyone, any other questions? Anything you want to ask, you can ask me.
I had one side question if we were going to cover Ether channel layer 3. I don't recall us covering that at all.
I'll see the that thing also, don't worry. Ether channel about layer 3. Okay, we'll see that thing. We'll go step by step. Okay, so don't worry, we'll see Ether channel, layer 3 Ether channels also. Okay, Robert?
Got it. Thank you.
Now we have something known as SPAN, RSPAN and ERSPAN. Have you heard about these things before?
Yes.
Yes.
So SPAN is something switch port analyzer, or you can say it is also known as port mirroring, or you can say it is also known as session maintaining. Now this is something Cisco Catalyst switches support, a method of directing all traffic from a source or source VLAN to a single port. This feature is called SPAN. Now, how it is used, when it is used, when SPAN is used. So suppose I'm working in a BPO, okay, and I want that my recordings or all the recordings should get stored at one place. Okay, so I am having a switch over here and my user is connected to the switch. What I did, I connected a server over here, and I want that whatever the voice traffic or whatever the call recordings that are getting records. Okay, so one of the copy of that recording should be stored in the server, in this server, and whenever this client want this recording, he has to request from the server, and the server will give the recordings. So SPAN is something that whenever my traffic is moving outside or it is moving somewhere, okay, so one of the copy of that traffic will be stored in the server, and SPAN is on the same switch. This is my source and this is my destination. Source and destination will be on the same switch. Okay, so you can say it is, as I told you, it is also known as port mirroring and session monitoring traffic for compliance reason, data collection purpose, or to support particular application. Okay, or to support particular application. Now, as I gave you the example, all traffic from voice VLAN can be delivered to a single switch port to facilitate call recordings in voice over IP networks. So basically it is useful. I can show you the diagram over here. The traffic flows through the switch on the internet. Okay, this is a span running on switch. Okay, there is a span running on switch. The client sends the data goes over here, but a copy of the traffic flow sent to the packet capturing device. Okay, now it is useful for many applications, which includes, you can say, as I told you, monitoring traffic for compliance reasons. Okay, and another common use of this feature is to support intrusion detection or prevention systems like in IDS or IPS security solutions. So these can be used in the security solutions also. Okay, so SPAN is something that if my source and destination are connected to the same switch, I want my traffic to be stored. I want my traffic flow to be captured by a capturing device, or it should be stored in a server so that I can get it up. If I want in future, if I want that traffic, then I can get it from there. Got it? Understood?
Yes.
Hello.
Yep.
Does this work like a syslog server, something like that?
Sorry?
I'm saying that does it work like syslog server? Like, does it work like that?
Syslog will store your log messages, events that are occurred. It will not store your events that are occurring. It will store a copy of data, whatever the data is traveling from the switch, from that particular source to that, if any destination. Okay, from that particular source. Suppose I have a 24 port switch, and what I did, I said that fast Ethernet 0/1 port is span port. Okay, so what I did, I am saying that any traffic that is going outside from this port should be stored, a copy of that data should be stored in the capturing device. Got it?
Okay.
Syslog, what it does, Syslog will store your, what do you say, it will store the messages, the events that occurred. Okay, so span is monitor traffic sent or received from an interface. Okay, and you can give an in direction or you can give an out direction. Okay, this is a switch that I am having, and I want to configure on this switch. I need to configure what? Fan. Okay, so why this doesn't work at my laptop? So I have four interfaces over here: 0/0, 0/1, 0/2, and 0/3. Now my task is I'll mirror the traffic, okay, that is sent or received from interface 0/0. Okay, my task is First task is mirror the traffic sent or received, any type of traffic. Mirror that traffic. Mirror means store a copy from interface E0/0. Okay, this is my source. Okay, to interface E0/3. I have to store this traffic. I have to send the copy of the traffic to this interface E0/3. I have to send the traffic to this interface. Okay, understood?
Yes.
This is my task. Small task I am taking. So how I need to configure? So the configuration starts monitor session. Monitor session. And I need to give any number, span session number, any number between 1 to 66. I'll start with 1. Okay. Monitor session 1. Then it is giving me the destination, filter and source option. So I'll select the source option first. What is my source? See, source can be either any interface or it can be a VLAN, a particular VLAN. Okay, so source is my interface in my scenario, E0/0. E0/0. Okay, then monitor session 1. Now I have to give the destination interface. So destination interface is E0/3. E0/3. Monitor session 1. Source interface is E0/0. Monitor session 1. Destination interface is E0/3. Show monitor session 1. Here I am getting source port for both the type of traffic is E0/0 and destination port, that is E0/3. See, I cannot see over here the particular type of traffic. I cannot pass any traffic, or I can check why it is happening.
It keeps crashing on me too.
Sorry, it's getting crashed.
Yeah, it crashes on me too every time. It
Yeah,
pops that
might
error
be.
at the end and
I
dies.
think so. This is not supported in this EVNG span things. I don't know whether this is there over here in packet tracer. Otherwise, we need to take a layer 3 switch in GNS3 and we need to try if it is not there over here. So IP interface brief. Okay. Monitor session 1. Source is my interface fast Ethernet 0/1. Monitor session 1, destination is my interface, fast Ethernet 0/20 suppose. Show monitor session 1. Whatever I've configured over here, you can see. Okay. Now we have two types of traffic, as I've written over here, sent and received. Okay, sent and received. Okay, so we have two types of traffic over here. So we have two options for both the type of traffic. RX is for received traffic. Any received traffic on a particular port, if I select RX, then the switch will make a copy of that received traffic, and it will store it on the destination port. Okay, so and if I select TX is for transmitted traffic. And transmitted traffic is like if anything is transmitting from my source port, then the traffic will be stored, the mirror traffic will be stored on the destination port. If I don't select anything, like I did in this example, I didn't select any options over here. After this, I didn't select source, interface, RX or TX. I didn't select anything. Like I'll be having an option over here. If I give you the things, if I give you this, I'm having an option RX, TX, and both are by default. Both are, if I don't say anything, it will select as both. I need both type of traffic to be stored. It is a default thing, you can say. It is a default thing. If I don't select anything, by default it will make the mirror of that traffic of both the type of traffic, received and transmitted. Got it? Any questions? Let me take some one more example. I'll configure.
Sorry, I have a question here.
Yep.
For instance, we have about 10 servers on the network. So does it mean that we're going to configure all the 10 interface pointing to the servers for this particular?
If I'm connected with 10 interfaces and 10 interfaces are my source, correct? So if I want that traffic from all the 10 interfaces to be copied on, to be made mirrored on the destination, then I'll make all the 10 interfaces to run, to give this command. I'll give this command for all the 10 interfaces. Understood? Suppose I am running, what example I gave you, suppose I am running a BPO. Okay, I'm running a call center, a BPO, and what I did, I want that whatever my clients or whatever my agents are talking with my customers, the call should be recorded and the recordings should be stored in a particular server. So I might be having many agents, okay, at the same time, and they will be connected to different switch ports. So if I want, what I can do, I can make this several ports as my source port, but only one port will be my destination port. Destination port can be only one port. Got it? I guess.
I'm not clear. If you can demonstrate on the diagram. My question is, we want to monitor, let's say, 10 interface. So how are we going to implement this? Because what you have done is only one-to-one. So in the case of multiple interface, how are we going to implement it?
This is the second interface. This is the third interface. This is the fourth interface. So I got 4 interfaces. Show monitor session 1. My source is from these many interfaces. Any traffic that is coming from these interfaces will be stored over here on this destination port.
Okay, that means you have to enter it one by one.
Yes, or you can
Okay.
in this line also.
One question to you. Let's say if we mirror three ports, three 1G port on one destination 1G port, will there be any impact?
Sorry, come again. 3 ports on?
Three 1G port, right? 1 gig port. If we mirror three 1 gig port on a 1 gig port F020, so 3 Gbps data, right? Let's say it is full congested network. So 3 Gbps can be mirrored to F020.
Yes, the destination port can handle several types of traffic. Okay, it can handle multiple traffics from multiple source at the same time.
What about the port capacity, transmitting rate?
See,
So,
it will be queued. It
okay.
will be queued. We will be running some of the some of the quality of service protocols. Okay, we will be having some QoS policies also, so that the traffic will be queued one by one. Okay,
So
we
there
can
will
make
be
queuing
no
over
drop,
there.
right? Everything like 3G, like here in this case, 3 ports traffic. So maybe it's 3 Gbps. Let's say 3 Gbps. Those 3 Gbps can be mirrored on one gig port, which is F020.
Yes.
Okay.
Okay. Now my second configuration will be, I'll configure a switch, suppose to send the following, I'll make some list, following traffic to interface, any interface I can take. Suppose I'll take fast Ethernet 0/24, the last interface, processing the encapsulation from the sources. Okay. So what I need to do, I can say the traffic that is received on interface fast Ethernet 0/18. Okay, that is RX traffic. The traffic that is received on interface, any traffic that is received on fast Ethernet 0/18. Okay, will be mirrored to fast Ethernet 0/24. Sent on interface fast Ethernet 0/19. Any traffic that is sent on the interface, that is TX. Okay. Then sent and received traffic. Sent and received on interface. You can say any interface fast Ethernet 0/19. Okay. Now this is my trunk link, which is trunk, you can say. We also need to filter, or you can say remove VLAN 10, 20, 30 and 40. We need to remove VLAN 10, filter. We need to filter VLAN 10, 20, 30 and 40. Okay. From traffic coming from the interface fast Ethernet 0/19. That is my trunk port. Okay. So what I need to do, I need to filter these VLANs. Okay. And I need that these VLAN should be filtered. So I can do, see, I cannot see the output. I cannot show you the output in this thing, but I can check if I'm having a filter option over here, or else we need to go monitor session 11, suppose. Filter option is not there. It is not supporting in my that. What is my thing over here? I need to change the port numbers now. These are my port numbers now. I need to change. Fast Ethernet, suppose 1/0. And the destination will be 1/15. 1/2. 1/2. So the command is monitor session for the first type of traffic received on the interface fast Ethernet 1/0. I want any traffic that is received on the interface fast Ethernet 1/0. So monitor session, then the number, then also it is not working. Monitor session 1. Okay. Source is my which port fast Ethernet 1/0. Okay, and what type of traffic I want? Sixteen switch ports I am having 1/0 to 1/915, correct? Then why it is not taking the command? Source is interface I have to give. Interface fast Ethernet 1/0. And the type of traffic I want is RX from this interface. Then I have interface. The other interface is which interface? 1/2. Any traffic that is sent from 1/2. 1/2. And TX traffic over here. Any traffic that is sent from 1/2. Correct? Then I need to say third thing is sent and received on 1/2. So I'll make it not 1/2. I'll make it something 1/3 because 1/2 I have already used 1/3. Okay. Here also I'll make it 1/3. So if I want to take sent and received, I will not give anything. By default, it will take both the type of traffic. Okay, source interface is this. And the fourth one I need to do is I need to filter the traffic from these VLANs. Okay, VLAN 10, 20, 30, 40. Okay, so I'll create VLAN 10, 20, 30, and 40. Show VLAN brief. Show monitor session 1. See, I'm getting any source that is any source, any traffic that is received on 1/0 should be monitored. Any traffic that is sent from 1/2 and both the type of traffic on 1/3. So I can do specific configuration for specific ports. Okay, I can do specific configuration for specific ports. And now I need to monitor session 1 filter VLAN 10, 20, 30, 40. Filter VLAN 10, SPAN VLAN filter is not supported. SPAN VLAN filter is not supported by this switch. Let it be. But the command is this: if you want to filter a particular VLAN, okay, on that port, if you want to get the traffic, or you want to remove a traffic from that particular VLAN, you can give this command. Okay, then monitor session 1. Destination is interface fast Ethernet 1/15. 1/15. Show monitor session 1. See over here. Source is my 3 ports. Okay, I am having 3 ports as my source, and 3 ports, those 3 ports are having different types of traffic. One is having received, one is having transmitting, and another is having both the type of traffics. Understood? This I can do. This is known as SPAN. This is known as SPAN.
I have it working on my physical switch if you wanted to look at it that way or show everybody the command.
Yeah, I can show. So I'll just stop the sharing and you can share the screen now, Robert, and you can show everyone the output. Can you please increase the font?
Yes.
Thank you very much. So just go in the global configuration mode and give a command, do show history. Whatever command you have given will be coming over here. Okay, so see what I've done. I have filtered these VLANs. I have filtered these VLANs. Yeah, just show the output filter VLANs 10, 20, 30 and 40. Okay, and so both the traffic you have taken for RX, just make it the fast Ethernet 0/2 port for transmitting traffic. TX, make that port as TX. Yeah, just remove this that command and just give the new command. Then now show me the output. Yeah, this is the output RX, TX and RX, TX, and give one more command for both the type of traffic on any other interface fast Ethernet 0/3. Give the command monitor session 1.
Okay.
For both the type of traffic, monitor session 1, and the source is interface fast Ethernet 0/3. That's it. That's it. Yeah. Now give the command again.
Yeah.
Now you can see both the type of traffic. Understood?
Yes.
Guys, any questions? Okay. Okay, so this is something SPAN. Okay, if the source and destination are on the single port. Then we have RSPAN. RSPAN, it will specify that the you can say RSPAN is something like the destination port for the span session can be on local switch as in the span operation, and it can be a port on another switch in the network. This is known as remote span. Now we are having two switches in our network and my destination port is on another switch now. Now that is something my remote span. If I am having the if I am having the the destination port on the same switch, then that is span. If I am having the destination port on another switch but in the same network, that is remote span. Got it? Like you can see in this diagram over here. Traffic flow across the trunk link, RSPAN VLAN is carried over the trunk link to RSPAN running on the switch. RSPAN running on the switch. Okay. A copy of traffic flow. Now this switch is connected over the internet or something outside the world or something anyway. Now a copy of traffic flow to be sent, where it to be sent to the packet capturing device. Understood? This is my RSPAN.
So with RSPAN, I mean, if you're capturing a specific VLAN, that has to be permitted over the trunk itself before you can actually capture it. Okay.
Yes. It has to be permitted over the trunk link. If you are configuring any VTP configurations.
I see.
Okay, then now how to configure RSPAN? RSPAN configuration, you need to specify that the new VLAN is an RSPAN VLAN. We need to create one VLAN. Now here what we were doing over here, in if we are having one switch, so we were giving that this is my source port and this is my destination port. Now here there is the VLAN, the source port is on one switch and the destination port is on the other switch. Now what do we need to do? Now we need to create a RSPAN VLAN. We need to create a RSPAN VLAN. Okay, and we will specify that the new VLAN, we will create a VLAN and we'll specify that this new VLAN is the RSPAN VLAN. And RSPAN VLAN cannot be assigned to any access ports. Okay, requires a separate RSPAN session to be configured. Separate destination session to be configured. Okay, so you need to check these all things to be checked before configuration. Trunk must be trunk must allow RSPAN VLAN. VTP is optional. If VTP is enabled, disable for RSPAN VLAN. So we'll not see the VTP things. Trunk, we will see the trunk thing. Okay, we can connect two switches and we can see the configuration, how to configure the things. So let me configure it over here. You have two switches, right, Robert?
Yes, I do.
So you can do it with me, and if I don't get the output, we can show the output at your side. Okay, now what I said, I need to make the link as trunk link. So first I need to create a VLAN. So I'll create a VLAN. Suppose I'll create a VLAN 99. VLAN 99. And I'll make this VLAN as remote span VLAN. So how to make it? I have to give remote span. First, I have to go and I have to give a configuration as remote span. Okay. Show VLAN remote span. It will not give me. See here it is showing me remote span VLAN is VLAN 99. Understood? Remote span VLAN I created. This is the first step. Okay. Then the second step, I require, as I told you, I require a separate remote span VLAN. Okay. So I will be creating on switch 1 also and switch 2 also. Enable. VLAN 99 and I'll say remote span VLAN. This is my remote span VLAN. Remote span VLAN is VLAN 99. Okay. Now let me jump back to the switch 1. Suppose there is a server connected over here on switch 1. Okay. And this is my switch 1. This is my switch 0. So on switch 0, I'll be having the source port. And on switch 1, I'll be having the destination port. So on switch 0, I'll say monitor session 1. Source interface is my any of the interface fast Ethernet 0/1 with RX traffic, received traffic. Any traffic that is received on this interface, you have to send a copy of that traffic to the destination port. 1/1 is, sorry, 1/1 is something that is connected to, what is that? Okay. Monitor session 1, source is my fast Ethernet 0/2 RX traffic interface. Okay, RX traffic and interface fast Ethernet 0/1. I'll say switch port mode trunk, switch port trunk. So by default it will take that only. So I've made the fast Ethernet 0/1 as trunk port. Okay. Then here what I need to give, the destination will be my monitor session 1. Now the destination will be not a port. The destination will be a VLAN. I'll send this traffic to VLAN 99, which is my remote span VLAN. I'll say destination is VLAN 99. Destination is VLAN 90. Sorry, destination is my remote span VLAN, remote VLAN 99. Destination is my remote VLAN 90 incomplete command. Why it is giving me incomplete command? Monitor session. I don't want reflector port. Monitor session 1 destination remote VLAN 99. Is it working on your side?
Yes, I was able to put that command in.
Yeah, it should work. I don't need the route reflector port. I don't need any port to get reflected by this thing. Okay, reflector port is fast Ethernet 0 slash fast Ethernet 0 slash 1. Suppose if I get now here on switch 1, which is my destination switch, here the source will be my VLAN, because see how my traffic is flowing here. My traffic is coming from any source port, and I'm saying that the destination is VLAN 99, and VLAN 99 traffic is moving through this trunk link. It is moving through this trunk link. When this switch will receive, it will be a source. VLAN 99 traffic will be a source, and the destination will be any port over here on the switch. Understood?
Now, what are we monitoring on the VLAN 99 specifically?
VLAN 99 is to just pass the traffic. VLAN 99 is just to pass the traffic. We are not monitoring anything of VLAN 99. VLAN 99 is used to pass the traffic. Okay, it is my remote span VLAN. It is my remote span VLAN, which is used to pass the traffic from one switch to another switch.
So can we say that we can configure a VLAN and then assign it to a particular service and then monitor?
Sorry, can we do what?
Can we configure a VLAN and assign it to a particular service and then monitor it on the interface as per this technology?
I didn't got your question. Come again.
Okay, VLAN 99. VLAN 99.
Mm-hmm.
Yeah. So can we say this particular VLAN will be assigned to a monitoring tool?
It will be used
and then
to
we monitor it.
It will be used to transfer the traffic. Okay, whatever the see how it runs, this RSPAN, how it exactly runs. Suppose here what I told you here, there is some PC connected, some users are connected over here, and users are sending the traffic. Okay, my user is sending a traffic over here. Now, previously, what was the scenario? My source and destination was on the same port, same switch. So there was no issue. But here my source is on one port and one switch, and destination is on another switch. So what I need to do? I need to pass the traffic from between this switch, okay, between these two switches. So what I did, I made this link as trunk link, because might be possible I might pass different VLAN traffic. So to pass different VLAN traffic from the source switch to destination switch, I need the link as trunk link between the two switches. So my link is trunk link between the two switches. Okay. Then what I need to do, I need to say over here, this is my source. Okay. Now I cannot say on this switch, I cannot say that the port that you are asking for the destination is on another switch. I cannot say that thing. What I need to do, I need to be on this switch only. So my VLAN traffic can pass from this trunk link. So what I did, I said that VLAN 99 is my destination. So any traffic that is coming from source, it will be forwarded to VLAN 99. And my VLAN 99 traffic is passing from this trunk link and it is reaching over here. Okay, it is reaching on this switch. When it reaches on this switch, this VLAN 99 traffic will become the source because it is coming from somewhere. For this switch, it will become a source. And the destination I will give over here is any port number. If anything you received from VLAN 99, you have to send it to destination port, suppose fast Ethernet 0/24. Understood?
Understood. It's the same thing I'm saying. Like say a server, we have a group of server, we put them in a particular VLAN. So in this case, we will just configure and then monitor those VLAN over the
Now
trunk
suppose
link.
your question is, these three are the users, I put them in VLAN 10, correct?
Yes, yes, exactly.
Now my source is this VLAN 10. This is my source. All the users in VLAN 10. And as I told you that this remote span VLAN will be not a part of any access port. We cannot assign this VLAN to any of the access port. So this will be not a part of any of the port. So what I will do, I will say this is my VLAN 10 users are my source and this is my destination on this switch. Okay, now my what VLAN traffic will be traveling? VLAN 99 traffic again is traveling over the link and it is getting over here. And now here this is my source and the destination is any port number or any particular VLAN. Suppose I said it will be VLAN 10 destination over here. Got it? I guess.
Yeah, I'm a bit confused. I'm not sure I'm getting the concept.
Okay, let me configure it completely. So I've given the source, then I'll give the destination over here. I'll say monitor session 1. What I gave over there on switch, on this switch, what I gave, do show history. I gave destination is my 99 and source is not showing over here because the number of commands exceeded. Source, what I give, source is my fast Ethernet 0/2 interface. Okay, fast Ethernet 0/2 interface is my source and destination is my remote VLAN 99. Now my remote VLAN 99 is traveling from the trunk link and it is received on the switch number 1. Now I am saying the source is remote VLAN 99. Whatever you receive from remote VLAN 99, you have to send it to destination interface fast Ethernet 0/24. Show monitor session 1. See, source is my RSPAN VLAN. Destination is my fast Ethernet 0/24. But if I go on switch 0, show monitor session 1. My source is what? Fast Ethernet 0/1. So this did not got removed over here. That was the reason it was not forming the trunk. So both type of traffic on fast Ethernet 0/3, 4, 2, 3 and 4. And the destination is my remote VLAN, remote span VLAN on the same switch. It is on the same switch. See, I'll explain you again. I'm having 3 users. All the 3 users are in VLAN 10. Okay. Remote span VLAN is my VLAN 99. Okay, to pass multiple VLAN traffic, what I did, I made this as trunk link. Here is my source, and I want the server is kept at fast Ethernet 0/24 on the other switch. The server or the mirror capturing server that is kept on the other side on the other switch. Okay, and that switch is something that I want the data should be stored on the other switch. So what I can do over here now, so what I did over here, I said these VLAN 10 users are my source, and I have created this remote span VLAN on both the sides. Okay, so what I said, my traffic, that is incoming traffic or outgoing traffic, whatever traffic that is coming from these VLAN 10 users should be sent to remote span 99. Should be sent to remote span 99. Now my remote span are on the both the switches, so remote span will be traveling from here. 99 traffic will be traveling, whatever the traffic is there. So this is my source on this switch, and this is my destination on this switch. Now when it received over here on this switch number 1, this became the source. This became the VLAN 99 became the source, because I am getting the information from one switch. Okay, I am getting the information from a switch and the VLAN 99, and where I have to send it, I have to send it to this destination, fast Ethernet 0/24. I guess.
Yeah, perfectly. I grab it. Thank you.
Understood? If you
Yes.
didn't understood, you can ask me again. Don't be confused.
I think I understand. Everything's from the perspective of the switch, right? So the switch says the source is the individual client's destination is the VLAN. So we go to the next switch or several down the road, and it says the source is everything's coming over VLAN 99. So that would be the source, destination being where the
See,
output
what
should
I'm
go
doing
to.
over here, see, there might be on this switch, there might be some users that are my source. Okay, on this switch 1, which is having the destination. So here I will be running span. Here I'll suppose my fast Ethernet 0/10 port is my source. So on the particular same switch, I'll be running span. For this switch, the destination is this. Okay, but anything that you receive from this VLAN 99, anything that you received from VLAN 99 will become my source. And what I need to do, if anything I received from VLAN 99, I have to store it on the server. Got it?
Yes.
Okay, so let us take one more lab. I'll reload these switches so that the configuration
But
becomes.
then I would like to ask, is it configured on the router too, or only switches?
Sorry, the span thing.
Yes.
You can
Can it be
configure it on
configured on the router?
layer 3. Layer 3.
Yes, layer 3.
Yeah, you can configure it on layer 3 also.
Okay.
Okay, so now I'll make some task over here. Let me say we need to configure Two switches. We have two switches. Okay. To send traffic to RSPAN VLAN. Now here my RSPAN VLAN will be 199, suppose. Okay. Which is delivered to port fast Ethernet 0/24 on switch 2 or 3, any switch I can say, switch 2. Okay, I can say switch 2, or let me take one more switch. What I'll do, I'll take one more switch over here. Now these are my 3 switches that are connected with each other. Okay, that will be, I'll be connecting them with each other. Okay, so
हेलो कయ్यूम, एक डाउट था मेरा।
बोलो ना।
अच्छा, ये जो स्पैनिंग होता है ना, वो मतलब कितने पोर्ट कर सकते हैं एक पोर्ट पे, मतलब मिररिंग?
मतलब समझा नहीं, कितने पोर्ट आप सोर्स बना सकते हो?
हाँ,
बना सकते हो सोर्स, आप कितने भी पोर्ट बना सकते हो। वो रिस्ट्रिक्शंस हम देखेंगे क्या क्या रिस्ट्रिक्शंस है जब हमारे ये कंप्लीट हो जाएगा ना, ठीक है, तो हम देखेंगे कि क्या क्या रिस्ट्रिक्शंस है।
अच्छा अच्छा, ठीक है।
डोंट वरी, उसके बाद मैं आपको बताऊंगा क्या क्या रिस्ट्रिक्शंस है, क्या क्या कैसे हम वो कर सकते हैं, कॉन्फ़िगर कर सकते हैं, क्या हम कॉन्फ़िगर नहीं कर सकते, वो सारी चीजें मैं आपको बताऊंगा।
ओके,
ठीक है, सो मैंने ये स्विचेस कनेक्ट कर दिया। ठीक है, अब ये जो स्विच है वो अब आपका यहाँ पे आपका रूट ब्रिज वो सब सिलेक्शन हो जाएगा। ठीक है, जस्ट गिव मी अ सेकंड। ओके, सो मैंने क्या किया, स्विच 1 पे गया मैं, enable. So what I'll do over here, I'll create some VLANs over here. Okay, suppose VLAN 199. First of all, I need to create VLAN 199 and I have to make it as remote span. Okay, then I have given you the task. Okay, I have not given the task. Will it be switch 3? Now from switch 1, all traffic received on VLAN 66 to 68. Okay, I want whatever traffic that is received on switch 1 on particular VLAN 66 to 68, I need them to be monitored. On switch 2, all traffic received on VLAN 9. Okay, from switch 2, all traffic sent and received on VLAN 11. Okay, so these are my tasks. My first task says switch 1, on switch 1 all traffic received on VLAN 68 and 69. So this is my switch 1. Suppose host name, I'll change it to switch 1, switch 1. Okay, monitor session 1 Source is what, my VLAN 66 to 68. And what type of traffic? Received traffic. Correct? Got it? What is my destination for all the ports, for all the things? Here is my destination. I have to send the traffic to remote span VLAN 99. Okay, so I've given the source. So on every switch, I have to give a source and I have to give a destination. So destination is my remote VLAN 199. Again, this thing. Why it's happening, I don't know. Should not happen. Robert, can we do one thing? You are doing side by side, right? So you can show your screen. I'll just give you the commands. Whatever commands you need to use, you can just enter the commands. We can see
Okay.
at your side. Just
We'll
check.
have to kind of start over. I didn't get all the commands in there, but let me share my screen.
You have written all the commands?
I've just been observing. I was watching that time. But I have everything here. So
You have two switches, right?
yes, I got switch 1, switch 2.
Yeah, no issues. We can do that with two switches also. So create a remote span VLAN first. VLAN 99.
Okay.
VLAN 199 will be your remote span VLAN. No, not name, not name. Don't name it.
Yeah.
You have to give the
Okay.
command remote span VLAN.
Okay.
No. Over here only. Inside VLAN 199, you have to give the command remote span. Yes. Enter. No. Enter. That's it. This is how we
Okay.
create remote span VLAN. Okay. Now exit. Now give the command monitor session 1. You have reloaded, you have cleared the previous things, right?
Correct. So if I do show run type include session, nothing there.
Yeah. So monitor
So monitor session
1. Source is my VLAN 66 to 68, 66-68, and RX traffic. Yeah.
Okay.
Yes. Then monitor session 1. Destination is my remote VLAN 199.
Yeah.
Yep. So here it is working. Okay. Now go on switch 2. So here what I will do, I'll make a
Then you do the
remote
VLAN.
VLAN. Yeah.
Gotcha.
Okay. Now here on this I'll make the source monitor session 1. Monitor session 1 because we are having only two switches. So monitor session 1 source is my VLAN remote VLAN 199. Okay. And destination is my, you can say destination is my fast Ethernet. Any port you can select. Any port that you have on your switch.
Hold on, sorry.
So here we can keep different session name also, right? Session
Yeah,
1.
you can create different sessions.
Yeah, we can do also 2.
Yes, but on both the switches, if you want the source and destination for the particular session, it should be same on both the switches. Yeah, hit enter. That's it. Now give the command show monitor session. One. See now over here, the source is my remote span and destination is my port fast Ethernet 1/0. And if I go on the switch 1 and if I check, my source will be VLAN that I have numbered. I have given in the list. I have given in the list both the type of traffic. Why it is taking both the type of traffic? Because previously the command that was given is not removed. That is the reason it is taking both the type of traffic. Okay. So if I give only RX or only TX, it will give me the particular output. So you can do for multiple switches, you can select one destination port. Okay. So here we are not having multiple switches, so I cannot show you.
Do we need to allow 199 VLAN on trunk?
Yes. So you need to make the trunk link. You need to allow the 199 VLAN.
Okay.
Yeah, that was written in the rule. That was written in the rule. Specify that the new VLAN is RSPAN VLAN, and RSPAN VLAN cannot be assigned to any port. Requires a separate RSPAN session, separate destination to be configured. Okay, and trunking to be that trunk must allow the RSPAN VLAN. Trunk must allow the RSPAN VLAN. Got it?
Yes, dear.
You can stop the screen now, Robert. Thank you.
Yep.
Yeah, you can stop the share. So remember this thing, these rules. These rules, remember these rules.
Can you show me the task list that you had in Word, please?
Yep.
Okay, thanks. So, okay, thank you.
Yeah, EVNG will not support this thing because there is some issue. I will check with my Peanut lab. What is the issue with my Peanut lab? Why it is not getting open? I've done a lab yesterday only. Today it is not getting open. Why I don't know. So I'll check it why it is not getting open, and if possible, I will show you the things on this Peanut lab.
And I have a third switch. Well, it's an integrated switch module on a router, if that matters. We need to use that at a later point.
Yeah, we can check it. You can do it by yourself now.
Got it.
Giving me the authentication error, authentication of the problem there is with the things. Okay, no issues. So this is something my RSPAN thing. Okay, whenever my source is on one switch and destination is on another switch, I'll use RSPAN VLAN as my source and my destination things. Then I have ERSPAN. ERSPAN is used whenever you can say I am having the source in one network and the destination is in other network. The destination port that I want to store, the monitoring traffic that I want to store is on the other side of the network. Like you can see over here, we are having a layer 3 network separated and my source is over here on one network and destination is on other network. Okay, separated geographically. So creates a GRE tunnel for all captured traffic and allows it to be executed across layer 3 domains. Okay, supported on ASR 1000, Catalyst 65000, 7600 Nexus platforms. Monitoring sources include fast Ethernet, gigabit Ethernet, and port channel interfaces. Okay, so here we don't have any practical for this ERSPAN. You need to understand that whenever my source and destination are separated on different networks. Okay, then I need something known as ERSPAN, encapsulated remote span. Got it? Now span restrictions and conditions. Now source port can be any type of port. Either it can be a router port, source port, physical switch port, access port, trunk port, ether channel. If you have created an ether channel, it can be a port channel interface, or you can make a source VLAN as the source port. So source port can be any type of port. If you are making a span, then source port can be any type of port, either a router port, a physical switch port, an access port, any devices connected, any trunk port, and port channel interface, or source VLAN. These are the
Switch.
restrictions.
What
And
is router port on switch? Means we are talking about switch or router? Router port on
if you
switch.
have connected any router to the port, okay, to the switch port, then, or if you have connected any layer 3, if you are working on a layer 3 switch, okay, and you want that on that layer 3 switch, you are working as a switch also and as a router also, and you want that a source port on that switch will be a router port. The port that is working as a router will be my source port. So you can make that port as also as the source port in the span. Got
Okay,
it?
got it. Got it.
Destination. Destination is very important over here. Its original configuration is overwritten. Means the original configuration on that port is restored once we remove the span. Now suppose, what is the original configuration? Suppose you are having a switch and you have selected a port fast Ethernet 0/1 as your destination port. Now you have configured something like you have configured ether channel or something. This is a part of ether channel. Okay, so the port is removed from any ether channel bundle if we are part of any ether channel bundle. Okay, so and also if we have some VLANs or some ports that are assigned to this, some VLANs are assigned to this port, or I have assigned VLAN 1, okay, or VLAN 10 to this port, then that configuration will be removed. Whenever I make that port as the destination span port, whatever configuration is there, all the configurations will be overwritten. Okay, if it would be a router port, the span destination configuration overrides the routed port configuration. Whatever the configuration we have done on that port will be removed. Destination port do not support port security. We cannot configure port security on that port. Port security means what? We cannot configure any port security, you can say, any type of port security. Neither it supports 802.1x authentication or private VLANs. Destination port will not support any one of these. Destination port do not support layer 2 protocols. TDP, STP, VTP, DTP. If any of these are configured, it will be removed. It does not support. If this port, destination port, is part of any VTP domain, the configuration will be removed. But when we remove the span configuration from that port, the original configuration on the port is restored automatically. It will get restored automatically if we remove the span configuration. Understood?
No.
Which point?
I did not. Yes, the first point, the original configuration is overwritten. And you
Whatever
said,
configuration you will be doing, suppose you have some VTP configured on that port, or you have some VLANs configured on that port. Okay, suppose I assigned a port VLAN, I assigned a VLAN 10 to any port fast Ethernet 0/1, and later on what I did, I made this port as span destination port. I made this port as span destination port. So this VLAN 10 configuration will be overwritten. This will be overwritten, means this will be removed by this SPAN configuration, because whatever the configurations are there on that port will be overwritten. Whatever is the configuration, it will be overwritten. Okay, and once I remove this SPAN configuration, I remove that, I don't want this interface as my SPAN destination anymore, then whatever the configuration was there, it will come automatically. It will automatically get restored. Understood? I guess.
So we have a VLAN assigned to that interface. So when we configure a span on that, then that one will take over the span. It take over the
it will remove
initial
that port
configuration
from VLAN 10. It will remove that port from VLAN 10.
Okay.
The configuration will be not there. If we put any port in the VLAN 10 and the same port we make the configuration as destination span port, then that port will be removed from the VLAN 10 configurations, because it cannot be a part of any STP or any VTP or anything. It cannot be a part of anything. Got it?
Okay. That means it need to be a plain interface without any configuration.
It can be. We can have any configuration, but see what I told. We can have any configuration on the destination port, but when we enable SPAN, destination, all the configuration will be wiped out. All the
that's what I'm saying.
Wiped out. When we say this port is my destination SPAN, all the configurations will be removed from that port. Okay?
All right. Thank you.
Then some more restrictions and conditions. Source can be either one or more ports on a VLAN, but not a mix of these. Not a mix of these. Up to 64 SPAN destination ports can be configured on a switch. How many destination? 64 SPAN destination ports can be configured on a switch. Okay, switch port or router port can be configured as SPAN source or SPAN destination. A SPAN destination port cannot be a source port. Understood? Whichever port we have made as a destination port, it cannot be a source port. A source port cannot be a destination port. It's simple. Only one SPAN, RSPAN or ERSPAN session can send traffic to a single destination port. This was your query, right, Nilesh?
No, my query is not this. My query is, can multiple ports send can be source and destination can be one port?
Yes, so that's what we have seen. We have already seen the practical. There were multiple source port and only one was the destination port.
No, but what if the ports are working on a full bandwidth?
There is no issue. All the ports will be not sending the traffic at the same time, or we will be having some QoS policies. As I told you, we'll be having some QoS policies configured, which will make them, which will make the particular type of traffic to be coming. See, there are many type of traffic that will be passing through the interface, correct? And
so the traffic will be dropped if there is high bandwidth at all the multiple source ports, or what will happen to the traffic?
See, the traffic will be queued. It will be queued from.
No, Qayyum, I think we need to correct here. We actually work on these things. We have a product where we monitor, based on the mirroring. So queue cannot handle 2 gig data or 1 gig data. Queue sizing is very small. So that's why we should always assure that the destination port port should not be overloaded. If it is a 1 gig, then the traffic should be filtered, and filter traffic should be only, mirrored on the destination port, so that it should not be overloaded.
So
Otherwise,
that's what
there
I
will
was
be
telling,
packet
that
drop.
we will be needing some type of traffic to be stored. We will be not needing all the traffic to be mirrored on the particular port. Okay, we'll be needing some type of traffic to be stored on a particular server, like voice over IP traffic will be stored on a particular server.
Qayyum,
Yep.
don't think about storage. It is a simple configuration. You have 10 ports on the switch. I am mirroring 9 ports to all the 9 ports 1 to 9 to the 10th port on the switch. Okay, so all these 10 ports are, let's say, 1 GB, and the 10th port is also 1 GB. If all the 9 ports are running on a full bandwidth, will it be able to take all the bandwidth?
So you can say me what you are working on it. Okay, as Pawan said,
No,
you are
I
working
don't
on
think
it.
so. I don't think so.
So Pawan, what is your suggestion? What is your point on this?
No, we cannot mirror whole traffic. So either you based on some filter, or the 10th port should be 10 gig port. Then you can, take all the traffics on the port, 10th
What
port.
type of filter you will be adding? Can you please explain what type of filtering you will be
Maybe
adding?
based on VLAN, maybe based on TCP UDP, or some, like here in switch we have only RX, TX and VLAN filtering, 3 options, right? So we can do these 3 filtering options. But in our case, we do another, like tap is there, optical tap. So the tap can mirror up to 10 gig or 40 gig traffic.
So what I told was not what I told was something different, Pawan. As I also told that it should be filtered. Okay, the traffic should be filtered as per the.
No, but just one correction. You said only that queue will handle. Queue cannot handle those much traffic. Queue can handle queue sizing, is very small, right? So queue cannot handle big traffic. What 2 gig traffic cannot be put in a queue. Queue
Yes.
size is very small, maybe
Correct.
in MB. So that's why the destination port always should, we should always care the destination port not be overloaded. That's the point.
Okay. So what I said was wrong.
No, I'm not saying you were saying anything wrong.
No,
I said
see, I might be also wrong. I might be thinking something wrong. My concepts might be wrong. Okay. So there is nothing. See, we learn.
Because this we see challenges on our day-to-day activities. So we always ask customer to provide either optical tap, or the filter should be precisely implemented in the network. So the destination port should not be overloaded.
Okay. Okay, so can you please, Pawan, explain again one more time about the things so that all others can go through it? That how we will be making the traffic. Suppose we are having these conditions, okay, and we are having some. You can take any condition of your choice, and you can just explain if you can.
I will take same example what Nilesh is saying. Let's say we have a one switch where we have 10 ports, okay? So and if we want to mirror port 1 to 9, mirror all the 9 ports, and destination port is 10th. So those 9 ports are fully, fully utilized. So we have 9 gig traffic, right? So 9 gig traffic cannot be mirrored on port 10, because 10th is a 1 gig interface.
1 gig port. Correct.
So either make 10th port as a 10 gig interface, 10 gig SFP, or make some filter so that you will have only required traffic, type of traffic.
Those 9 ports are the part of one VLAN, or they are part of different VLANs over there?
It could be different VLANs, right? There is no restriction. We can mirror different VLANs traffic.
Yeah. So how you will filter the traffic? On what basis you will filter the traffic?
VLAN ID, yeah, VLAN ID.
VLAN ID, or that's it. We
Any-
have only one filter, right? VLAN ID only here.
Yeah. So we will filter the things on the basis of VLAN.
Yeah.
And what
any
you
per-
will see. My
we can
point
also
is,
filter based on access list, I believe.
we can have the filter on based on.
Access list.
Okay.
And
Robert,
access list we can apply at any layer, any source, destination, whatever you say. So
Or otherwise we will
creating a
have
filter.
packet drops. Or otherwise we will have packet drops.
yeah.
So yeah,
Traffic drop, not packet drop. Traffic will be dropped, discarded on the destination port.
Okay. Okay. So Robert, you got it? You understood?
Yeah, I think I understand.
Yeah, I want to
Okay.
ask, first of all, the destination interface, is it receiving the traffic or is just monitoring the traffic?
It will be receiving the traffic.
no. I mean, it's not about receiving or sending the traffic. It's
On the
about
10th port, on the port
yeah.
10, you can put, Wireshark and you capture all the traffic.
Hmm.
On the port 10, you can plug your PC, laptop, and you can capture, you can put Wireshark on your PC and you can capture all the 9 gig from the 9 different ports. Or there are other application, other server, other tools which capture and store all the data which is coming out from the destination port.
No, actually, the mirror port always functions in the egress mode. Okay, so
Yes.
there will be only TX, not RX.
Yes.
Okay, it will receive RX internally only.
Mm-hmm.
So internally, from all the 9 ports in our example, we'll send the traffic to the mirror port, and from let's say port number 10, it will be a transmit at the transmit end. All the packets from all these ports will be arriving, and then you can further send to any of your FTP server or whatever application that you want to analyze the traffic. So it only operates in the egress mode. That's the answer.
Okay.
Maybe I believe Qayyum, actually, if you can draw a small diagram, that will be helpful to all of us,
Diagram about?
if possible. I mean, maybe 2 or 3 ports which are mirrored to the span port internally, and the span port then takes it to some FTP server like that.
Okay. Okay, no issues. I'll make the diagram and I'll show you. Okay. Right now, I have to
Yeah,
stop
maybe after.
because it's 8 o'clock and I'm having a back-to-back lecture, as you people know.
Okay.
Yeah. So it's been 8:01 over here. I need to start. This recording will take some 10 to 15 minutes to get converted. Okay. So
Yeah.
the last point is span destination port passes only span related traffic. Okay. And any suggestion, anything you want, you can give me. Okay. And as Nilesh told me that a type of diagram that can help. I'm not getting what type of diagram, like, can you please elaborate it, Nilesh, about the diagram or what I need to do so I can get back to this? Nilesh?
Can you enable the annotate mode in the meeting? Annote.
Where are the
Simple.
settings?
What I'll do, I'll draw the diagram and send on the WhatsApp group. Okay.
Okay.